And good morning. I'm meteorologist Ross Ellett. Hopefully you can hear me all right. We'll get started here momentarily. Let me know if you can hear me, and I'll get logged in over here. Also, let me know where you're watching from this morning also. If it's locally, maybe it's across the country somewhere. All right. Well, just in a few seconds, we'll be ready to go. All right, looks good. Looks like the audio is in good place. If you missed this yesterday, we were talking about world weather, and this is week number 8 on Getting Schooled, and we were talking about more regional to worldwide kind of patterns that develop or that kind of transport moisture and warmth and heat across the globe. Today we're going to be talking about the jet stream, which is still right in line with that world weather, and also we'll be talking all about El Nino. Both of those kind of go hand in hand and can really impact our weather across the entire parts of the country and the world, for that matter. All right, so we'll get started here, and then, one second, let me just click on our live video so I can see the comments coming in here. All right, so we've got that going on. All right, so today again, El Nino and the jet stream is what we're talking about. Yesterday was all about the atmosphere and climate. Today and yesterday kind of working hand in hand with the same topic here. And then for tomorrow, we're going to be talking about basically weather history in Northwest Ohio and Southeast Michigan. So we're going to be going back and looking at some of the top 10. This is what I've got, pretty close to about 10 big weather events that have happened here. And there are interesting stories that go along with each of those. So pretty fascinating stuff. And I'm a big fan of looking back at some of the big weather events we've had, and I think that kind of lets us know what is possible going into the future. So we'll talk all about that coming up tomorrow. And next week, it's summer weather. And this has worked out really well because next week, it's going to be getting warm and in some cases hot and humid, or at least close to that. So it's certainly going to feel like a big pattern change coming up next week and even later this week for that matter. So that'll all work out pretty well for us. But let's go ahead and talk about El Nino. We'll take a zoom out from Toledo, and we're going to go all the way across the world here. So we've got clear down towards the equator. You've got South America, and wrapping all the way back off towards the west as it goes around the globe. And you got the normal trade winds that happen. Now, here at home, our winds are typically going west to east. Now, on a day like today, maybe those winds are slightly different. Maybe you've got a northerly wind or a northwesterly wind or a southerly wind or a southwesterly wind, but generally it's more west to east. Now, sometimes those winds reverse. Sometimes we get them off the lake. We call it a lake breeze. We talked about that a couple weeks ago on what it looks like when the breezes are coming right off of Lake Erie. Today actually is more of a light southeast wind, so that happens occasionally, but it's like 75% of the time our winds are coming either from the north, northwest, west, southwest, south. They're not coming from an easterly direction. It happens pretty typically. Now, this changes depending on where you're at around the globe. And as you go down towards the equator, the trade winds are straight east to west. And that's pretty typical of what ends up happening most of the time. And you can see those trade winds as they go straight from the east to the west, the opposite direction that our winds are coming from. What it does is it ends up allowing, it kind of pushes some of the warm waters that they have and pushes them farther off towards the west. And that's important because yesterday we were talking about the Gulf Stream and some of the ocean currents and how it is able to push and move some of these currents of warmth around the globe. How off of California, they've got cold water and they don't get hurricanes that often. Well, off of Florida and the Carolinas, they've got really warm water and they get hurricanes. So this has some big impacts around the globe, but certainly locally, and it has an impact as you head down towards the equator too. So the farther west you go, the warmer the waters are. Well, that leads to more potential for showers and storms and a lot more energy along with it. Now, that's what happens normally is, again, you're closer to Australia here, Indonesia, a lot of Pacific islands out there, Fiji, that type of thing. They would typically see more, those trade winds typically bring in some more of those showers and storms. the farther west you go. Now, that's all fine and dandy, but El Nino is actually the opposite here, to where those winds are not typically aren't all that strong. They aren't pushing things off towards the west all that much, and you get a buildup of warmth and energy a little bit closer to South America. So everything kind of shifts over. Again, this is so far away. We're talking 5,000 miles away. Why does it impact us here in Toledo? Well, is that shift happens globally. Now you've got drought in the western part of the Pacific. There's cooler waters there. They have a seafood shortage to go along with it. But as we get a little bit closer to our area, or a little closer to South America, it begins to alter the jet stream, and it begins to alter the weather conditions across the world, and it begins to alter things out towards California. And as the jet stream is different there, basically all across the country, it sets the stage for some different weather conditions. So this is a look. You've got 1997 there, and we've also got over the last several years, I believe that was 2016, that you've also got matched up too. And the warm is indicating where the ocean temperatures are above average. And you can see that huge spike that is taking place here. You got it right here's what we're talking about. This is 1997 going into 1998. This is a big El Nino year. This is 2016, same thing, huge El Nino here, or going into that season anyways. And you've also got some warmer than average temperatures already off of the California coastline, at least compared to average. So it's altering things a little bit around the globe. And as that happens, the jet stream typically is pumping in tons and tons of moisture here across Southern California. So they are wet. You can see that jet stream coming in. And essentially we have two jet streams that are really important. We'll talk all about the jet stream here in just a few more minutes, but the jet stream is basically the big storm track. That's the highway of storms across the country. It's pushing these right along. And if this is a powerful jet stream, in which case in an El Nino year it is, southern jet stream is very powerful, it's pumping in tons and tons of moisture that's, again, all related to El Nino, and it's putting right into Southern California, and they're getting a lot more. Normally, this jet stream may be combined here with this northerly jet stream, which is the Arctic branch, and usually there's a lot of cold air along it. But regardless, even if it's not, it's farther to the north. It's closer here to Washington and Oregon. That would be in a normal year, or at least northern California. It's not so far into the south. That's pretty unusual stuff. El Nino, or I'm sorry, we are talking about El Nino, La Nina, which is the opposite pattern. What ends up happening is you get an even stronger jet stream here in the northern part of the country, the northwest part of the country, and they get pounded with rain and snow, much more above average. So this is El Nino. What it typically does across the country is the southern part of the country is wet, it is stormy, it is cooler than average. We're into the deep south, and Florida is right in that ballpark too. 1997, 1998, that one year that we're showing there, that was a big year for severe weather in the wintertime for Florida. I remember my grandparents going down to Florida, as they typically did back in the 90s. And I remember getting these phone calls and asking about the weather conditions. My grandma was scared because there was these frequent episodes of severe weather that were taking place down there, and it all had to do with this pattern. But for us, that other jet stream, the one that typically brings in the cold air, well, it's much farther to the north, and that means the northern part of the country is warm, and for us, usually we're warm and dry because we don't have that active jet stream. Now, for La Nina, it's a total opposite. Well, partially. We're still typically warm, but we're much wetter than average. So El Nino, it's warm and dry. La Nina, it's warm and wet. Where's our cold weather typically come from? That's usually when we have a La Nada, basically nothing, okay? So we don't have an El Nino or a La Nina, it's just normal. If it's in a normal phase, typically it's pretty average on precipitation, but it's cold. So we've got those three phases that we look at, and this is essentially going into the winter. It has a big impact. Summertime, not much of an impact at all. There's a lot of other things that have an impact on our weather, but this is a big one going into the wintertime. So if looking at Toledo and looking at the seasonal amount of snow that we typically get, we've got the averages on the top there. If you look at the last 10 years, it's about 37.6 inches of snow. The last 30 years, it's 37.6 inches of snowfall. Last 126 years, and the snow average is lower. It's about 33.5 inches of snow. And I showed yesterday how the climate in Toledo has changed. And one of those changes is that we have more snow now than what we had 100 years ago. We have more rainfall now than what we had 100 years ago. So the top line kind of shows how those snow amounts have gone up a little bit in time. If you look at the bottom, El Nino, we typically get about 34 inches of snow a year. La Nina, it's 37 inches. And if we don't have anything, it's almost 40 inches of snow. So those are the different phases. If you want a big snowy winter, La Nina years are good. If you like it cold, you definitely want a La Nina where there's just a normal phase going on. If you don't like winter at all, typically warm and dry is what you're looking for, and El Nino will do that. Now, there are other things that impact our winter forecast other than El Nino, La Nina, or if it's a La Nina, but this is a big one that can really stir things up across the globe. All right, let's go over and talk about Jetstream at this point. So the Jetstream is the superhighway in our atmosphere that is pushing storms around the globe. This is what does it. In fact, so we'd like a jet stream to be there because if it's not, these storms, if they develop, or a lot of times, let's say a storm develops along a jet stream and then it kind of gets away from the highway and it gets lost, it could spin around here and not really move because there's not a whole lot of winds to push it away. We don't like that because it can rain for 3-4 days in a row and it's usually cloudy and gloomy and cold and that's not a whole lot of fun. We had that happen a little bit earlier. I think it was about a month ago or so. We had a cutoff low is what we call it. It was just spinning around quite a bit. But these jet streams, we've got the polar jet, which I was kind of showing you on that one map for the El Nino graphic. And this is the one, doesn't have a whole lot of moisture with it, but it really separates the cold weather here to the north and not so cold to the south. So if this thing plunges south of where we're at, typically we've got a lot of cold air coming in. The subtropical jet stream is the one down to the south. And this one, in this case, is close to Hawaii. There's Hawaii that I just circled in. And it's usually pumping in a lot of extra moisture and warmth. There's a lot of warmth to the south of it, and it's mild to the north of it, but it's usually pumping in lots and lots of moisture here. And you get these storm systems right along it. Now, there are occasions here. These are always fluctuating. Sometimes this jet stream might come down a little bit farther to the south like this. And sometimes this jet stream might come farther to the north at the same time and phase up with it and basically combine. Well, that's when we can get some of our bigger storm systems, especially in the winter, because you may have a storm that's coming off of this northern branch, and if it times out right, you got a storm coming off the southern branch, and then boom, they connect right in the middle, and you get this powerful, powerful storm. And that's what's happened during some of our biggest winter storms we've ever had recorded, like the blizzard in 1918, the blizzard in 1978, and there are many others that don't end up leading to blizzards that just drop as 4, 5, 6, 7, 8 inches of snowfall. Or heavy rain and wind or whatever it may be. But when these two jet streams work together, you can get a lot of moisture, a lot of extreme weather to take place. This will be a little more tranquil, a little calmer of a picture here on the jet stream map. This is another look here at the world. Now, this time, if you've seen a globe, and I don't have one with me, but if I were to hold up a globe of the Earth and basically sit it down and we're looking at the top of it, and that'd be the northern hemisphere. That's what we're looking at here. And so clear to the north, we've got the North Pole that is sitting up here, kind of in the middle. Whoops, we went backwards here one. But kind of in the middle, we've got the North Pole. We're down here in Ohio, in that yellow circle that I just circled in here. And there's an arrow pointing to Toledo there too. But the brighter the colors that you see around the globe here, well, that's going to be our jet stream, and the brighter the colors, the stronger the winds here. And so you can see how it kind of circulates through. There's one jet stream there. You've got another that wraps up into Canada and it comes down. And these two jet streams aren't totally working together, but they are fairly close in nature. So a lot of times in the wintertime especially, we're tracking two different jet streams that are kind of moving across the country in different locations, which is definitely interesting, makes forecasting the weather fun and interesting along with that. Here's a look underneath that jet stream, and you can see that if it goes up or down, usually it has a big impact on the temperatures. And in this case, you've got a big blast of cold air that was moving right through the United States here at that time, including here at home. And so you can see this big area of cold weather that was sitting here. Well, we were cold. Parts out in the Pacific Ocean were cold. Alaska and Canada were warm. There's more cold weather over here. And if you just start looking all across the entire northern part of the hemisphere, there are cold blobs and warm blobs all over the place. And generally, this is all balancing out one way or another. Now, let me see if I can go back here and just show you that jet stream again. I'll show you what was underneath. We'll kind of toggle back and forth. So here's the jet stream again. And where you see it going farther north, you've got some warmer areas. Where it goes south, you've got colder than average areas coming in. But here's a look at, again, the temperatures underneath of that jet stream and the impact it's having. But that jet stream is impacting everybody around the world one way or another. Everything impacts everything else. In this case right here, if Alaska doesn't have this big ridge that develops here, we don't get the cold across our part of the country. And so it impacts everything. As this warm air goes up, it basically kind of pushes the cold air out of Canada, and it comes right down into the United States, and we're dealing with it. Opposite thing happens too. If Alaska is super cold, typically we kind of get the balancing act of that, and we're going to be warmer here. But regardless, as you look across the entire northern part of the hemisphere, there's usually a balancing act happening with those temperatures around the area. So that's how the jet stream works together. And of course, El Nino has a lot to do with that as well. So that's what I've got for you today when it comes to getting schooled, talking about the jet stream, talking about El Nino, La Nina, La Nada. These are world patterns that have an impact on every single location across the world in one way or another. It impacts areas down, which showed you Australia, showed you all the way over to South America. What's happening there with the ocean water can have an impact on our weather in Toledo, Ohio, or for that matter, any other spot around the world. That's how interesting this is our weather is connected to every other spot around the entire globe, in a sense. Now, it's a little tougher for what's happening, say, in South America or on the southern hemisphere to impact us here, but it does happen. We just showed you El Nino, how that impacts the whole equatorial area, where the equator is at. But all of these impacts can have this domino effect all across the world. We're talking 5,000 miles away, some cases even farther than that. So go ahead and let me know what questions that you've got here for today. And let's see, it looks like Courtney's asking a question, which brings something up. I'm going to go and show you something else when it comes to El Nino. 1 second here while I get this pulled up. Let's see here. So I'm going to go what Courtney and everybody else listening here, I'm going to go to what's called the Climate Prediction Center. We'll throw that website in real quick. And this is a neat, hold on, let's try this. This is a neat website for anybody that's interested in climate prediction, anything like that, even drought. And there's all this information on this website. Oh, you can't even see what I'm doing here. So it'd be helpful if I go back. Okay, there we go. So Climate Prediction Center. And on this website, there's a lot of different interesting stuff on it. So we've got, there's a 6 to 10 day outlook. And you can see that most of the country, the part of the country has been really cold the last 2 weeks. It's going to be really warm coming up here in the 6 to 10 day outlook. The 8 to 14 day outlook is super warm. So there's a 6 to 10 day outlook, an 8 to 14 day outlook. There's a 3 to 4 week outlook, which shows some stormy conditions once again. So we're finally getting into the spring storm season, it looks like. There's a whole section here that shows more on what's happening with drought. So Colorado's got drought right now, California up towards Oregon State has got a lot of drought. There's also short-term seasonal forecasts on there too. So the Climate Prediction Center, they're expecting as we go into May and even June, and July going forward, that it's going to be stormy, and there's a slight chance of temperatures being around average to slightly above average. So there's all that information on there. I'm going to go to the side where it says climate and weather, and there's El Nino and La Nina there. So I'm going to pull that up and then go to historical information, and then we'll pull up historical years here. So there's a chart going all the way back, I think it's 1950, there it is. And goes all the way up until current. And so this chart here, which looks like it's very difficult to see. I don't know if I can pull this up a little bit, kind of maximize what we're looking at here. So this is a little better. So you can see a lot of these numbers on here. Some of them are black, some of them are blue with a minus sign, some of them are red, and you can see them shining and pointing out too. Now the red numbers, that's an El Nino. Blue is La Nina. And if it's black, essentially we're in that La Nada phase. There is no El Nino or La Nina that is sitting there in place. Now, you've got a bunch of different letters here too, like it says D, J, F. Well, that would be December, January, and February. So it's looking at that 3-month average of what's happening there. The next one would be January, February, March. So you're looking at these 3-month averages here of what we're looking at. And I'll scroll back down. So Courtney was asking, when was the last time that we had an El Nino? Well, actually, right now, we've been bordering the line of what we call a very weak El Nino, and we've been there throughout the winter season, and we've been there ever since. It's right at 0.5 to 0.6. 0.5 is the cutoff. If it was at 0.4, it would be a La Nada. So we are right on the edge of a very weak El Nino. And quite honestly, it's had some impact, but it hasn't had a major impact on our weather here. If you go back to 2016, and you see that 2.4, 2.5, 2.6, 2.5, 2.2, that is an extremely strong, in fact, record-breaking El Nino. The other time that we had something similar to it was back in 1999 that I had mentioned too. Actually, excuse me, 97 into 98 was the year. 99 was a strong La Nina that happened afterwards. But you can see those numbers too, they're very similar, 2.1, 2.3, 2.4, 2.4, 2.2. Both of those winters, we went into the winter and we didn't have hardly anything. We got some rain occasionally, it was warm, and we didn't get much snow at all. So when you get strong El Nino signals like that, it usually has an overwhelming impact on the world weather, and we usually don't get much of a winter here at home. That's pretty typical. This last winter, it was a weak El Nino, and we didn't have much of a winter either. Well, there was some influence from El Nino, but the bigger problem was that polar vortex decided it was just going to take control of everything, and it was so strong it didn't allow that cold air to expand down the United States. So there are other factors that have an impact on it too. All right, let me go over and see what other questions that I missed here. Okay, it looks like JD asking a question. Okay, it looks like the question I just asked. When was the last El Nino from JD? We had fun having a field day making fun of El Nino and La Nada. No doubt about that. El Nino, Spanish for the Nino. That's good stuff there. See, I don't know if I've missed any questions or not. I'll give it maybe a minute or two. If there's a question you got on El Nino, La Nina, La Nada, the Jetstream, or anything else we've talked about, which covers quite a bit, let me know. I think this is like the 23rd episode or something like that we've done. And just a reminder, coming up for tomorrow, we'll be talking all about Toledo weather stories. So we're going to be talking about the biggest snowstorm that we've ever had in Toledo. And it wasn't the blizzard of ’78 or the blizzard in 1918. Actually, you got to go back to 1900 for this one. So we'll talk about that storm. Also, we'll talk about 1918, that blizzard, 1978, but also some big tornado outbreaks. We'll talk about that too. And a record wind event, which happened in 1948. So some of these things that I don't think a lot of folks may be aware of because they were before a lot of us were alive. So anyways, I'm looking forward to talking all about that for tomorrow. Courtney asking, what happens if a jet stream runs into a warm area? So the jet stream typically is the dividing point between really warm air and air that's not as warm, and sometimes really cold air. It can be that dividing point. But the jet stream is kind of like a big conveyor belt. It's the super highway for storms. It's moving across the world. So the more intense that temperature difference is between the warm air and the cold air, the stronger that jet stream is going to be, the more powerful these storms are going to develop into being, and the quicker they can move across the country. And if, depending on some other factors, it may also have an impact on severe weather. When it comes to warm air in particular, when a jet stream is interacting with that would be more the subtropical jet stream that is separating the really warm and humid air from the air that's not quite as warm to the north of it. And usually what that does is it stirs up not only some powerful storm systems potentially, but it stirs up a lot of moisture with those storms. So in the wintertime, we may have two storms, one in the southern part of the country, one in the northern part of the country. Northern part of the country riding on that jet stream might be an Alberta clipper. And that would typically bring us some wind, a limited amount of snowfall, maybe an inch, maybe 2 inches, and usually not much more than that. And it would be a fluffy snow, not a whole lot of moisture with it. If we were to get the southern storm that would come in, we would get, it wouldn't be nearly as cold, but we would get a ton of snow or a ton of rain, depending on how that storm tracked. And so that's really the big difference. That warm, humid air, well, that ends up leading to a lot of moisture when these jet streams interact with them and help to form those powerful storm systems that get going as a result. Let's see here. Amanda's saying, somebody catch me up here. Amanda, probably the best thing we can do is once we end this session here, you can go back and watch it from the very beginning, and hopefully that'll help out there. If any other questions that I forgot about or didn't see or whatever it is, make sure to bring that tomorrow, and we'll talk all about that, and we'll go from there. So tomorrow, again, Toledo weather stories. I'm excited about it. Next week, we'll talk all about summer and the changing seasons, which, again, it's going to be feeling more like summer, and those seasons will be changing this week, or that's what it's going to be feeling like. I'll talk with you tomorrow.